So you can see here in the figure, we have shown you oil pressure relief valve. We will also show you on the real engine. You can see here in the figure, this is your oil pressure relief valve. Now in order to adjust the oil pressure, you need to loosen the lock nut. This is your lock nut. This needs to be loosened, and you can see the slotted head of the screw. This is your screw. This is your slotted head, and you loosen the lock nut here and turn the adjusting screw clockwise to increase the pressure and counterclockwise to decrease the pressure. So this is your oil pressure relief valve. This oil pressure relief valve is turned clockwise to increase the pressure setting and counterclockwise to decrease the pressure setting. Now coming to this figure again, you can see here, this is your lock nut. This is spring loaded. You can see the spring here, and this is your valve here. Okay. So if you tighten the lock nut here, it will compress the spring, its oil pressure setting will increase, and if you turn it counterclockwise, it will decrease the tension of the spring and you will have a lower oil pressure setting. So you can see here the oil supply is coming from the pump and it is going to the engine. So in case oil pressure in this line becomes more than the oil pressure which is preset through this valve, it pushes this valve back. The higher oil pressure will push this valve back and extra oil will flow out from this passage. This passage will open then, and this extra oil will flow from this passage to the inlet side of the pump. Once the system pressure is achieved, again this valve will go back and will seat and will in this path and will close the passage. So again, now this passage is closed and your oil is flowing from the pump to the engine. By means of this lock nut, you can adjust the oil pressure of the system. Clockwise turning of the screw increases the tension of the spring that holds the relief valve on its seat and increases the oil pressure. I have just now explained in the above diagram, in the previous diagram, that clockwise turning of the screw, it increases the tension of the spring and holds the relief valve on its seat and increases the oil pressure. Now counterclockwise turning of the screw decreases the spring tension and lowers the pressure. So by means of this screw, you can adjust the tension of the spring, in turn varying the pressure of the lubrication system. So this is your oil pressure relief valve, this is your regulator through which you can regulate the system pressure. The oil pressure is adjusted only after the engine oil temperature is verified. So this pressure adjustment is done only when your engine oil has attained the operating temperature. This is done so that because your oil has, in case it is very cold, then it must be very viscous, so your pressure settings might vary. So in order to have proper readings, your oil should be at the operating temperature, so proper viscosity is there, oil is viscous and the system pressure can be adjusted. Next component, a very important component, is the oil cooler. You can see in the figure, this is a oil cooler. The oil cooler is made up of a core enclosed in a double walled shell. This is your core and this is your shell. You can see double walled shell. This is one wall and this is another wall. So what is the purpose of the oil cooler? Since the oil is also absorbing heat from the various parts of the engine, so it also needs to be cooled. So the oil cooler is there so that the hot oil can be cooled and again made ready for lubrication. So this oil cooler, it has a core which is enclosed in a double walled shell. Copper or aluminum tubes with the tube ends formed to a hexagonal shape and joined together in the honeycomb effect form a core. So there are copper tubes or aluminum tubes. They are formed to a hexagonal shape. The ends are formed to a hexagonal shape and joined together in the honeycomb effect to form a core. The ends of the tubes of the core are soldered or braced or mechanically joined. So ends of the tubes of the core, they are soldered or braced or mechanically joined. The tubes touch only at the ends so that a space exists between them along their lengths. This is all along the length. The space exists between them and the tubes, they touch only at the ends. The oil flows through the spaces between the tubes while the cooling air passes through the tubes. So the spaces between the tubes, oil is flowing through it, and through the tubes the cooling air is passing. So we have seen this oil cooler. It has a core with a double walled shell. You have copper tubes or aluminum tubes with the tube ends of hexagonal shape and joined together to form a honeycomb effect. The ends of the tubes of the core, they are soldered or braced. The tubes touch only at the ends. Tubes are touching only at the ends all along the length. So the space between the tubes, the oil is flowing. Between the two tubes there is a space, your oil is flowing, while through the tubes your cooling air is passing. The space between the inner and outer shells is known as the annular or bypass jacket. Two paths are open to the flow of oil through a cooler. So through the cooler you have two paths during different occasions, and there are two possible paths for the oil to flow through the oil cooler. One path is when the oil is hot and it needs to be cooled. So the path followed by the oil when it is hot and it is to be cooled. From the inlet, you see this is your inlet here. From the inlet, oil flows halfway around the bypass jacket. So oil has come inside through this inlet inside the cooler. It has flown halfway through the jacket. You can see it has flown halfway through the jacket. It has come inside. It is coming like here, and you can see here in the figure it has come halfway through the jacket, enters the core from the bottom. It is entering the core. This is your core, and it is entering the core from the bottom and then passes through the spaces between the tubes and out to the oil tank. And so now the engine oil, when it is hot, it is coming through the inlet, passing through the jacket, halfway it has come, and from the bottom it is going inside the core. Now here it goes inside the core, then after flowing between the spaces through the tubes, it is made to flow out to the oil tank. See in the diagram, oil is coming inside, flowing through the jacket, enters the core, is passing through the spaces between the tubes and going out through this passage to the oil tank. During the flow through the core, oil is guided by baffles that force the oil to travel back and forth several times before it reaches the core outlet. Now another path that can be followed in this oil can follow in the cooler is when the oil is cold or when the core is blocked with thick or congealed oil. So in case if the oil is cold, it doesn't need to be sent through the oil cooler, it doesn't need to be cooled further, or when the core of the oil cooler is blocked with thick congealed oil. In that case you may have a different path that the oil can follow. In this bypass route, the oil passes from the inlet completely around the bypass jacket to the outlet without passing through the core. So in case when the oil is cold, it doesn't need to be further cooled, it enters through the inlet and passes completely through the jacket and doesn't enter the core, and through the outlet valve goes back to the tank. Next component is your oil pressure gauge. The oil pressure gauge indicates the pressure of oil that enters the engine from the oil pump. As we have mentioned earlier that the oil which is being used in the lubrication system needs to be pressurized, filtered and regulated. For pressurizing the oil pump was being used, but in order to verify the oil pressure of the system, we need to have a oil pressure gauge. The oil pressure gauge, it is a very important gauge, very important instrument in a reciprocating engine lubrication system. This gauge warns of possible engine failure or loss of oil pressure due to exhausted oil supply, failure of the oil pump, burned out bearings, ruptured oil lines, etc. As in a reciprocating engine, as soon as we start the engine, the very first thing to be observed is your oil pressure gauge. So just after starting the engine, the oil pressure gauge is to be observed. Oil pressure gauge should register within 30 seconds. Why we need to observe the oil pressure gauge? The oil pressure gauge registering means that the oil has started circulating inside the system, and now your rotating parts, the moving parts inside the engine are being lubricated. In case your oil pressure does not register within 30 seconds of starting the engine, we are supposed to switch off the engine and look for the cause. In case your oil pressure has not registered, that means your oil has not started circulating in the engine and your moving parts are not being lubricated, which may result in severe damage to the engine. So we are supposed to just switch off the engine in case your oil pressure does not register within 30 seconds. There may be several reasons why your oil pressure has not registered. We have to look for the cause. So oil pressure gauge is one of the most important instruments of the reciprocating engine. Another instrument is oil temperature indicator. In a reciprocating engine, the oil temperature bulb is located so that it measures the temperature of the oil before it enters the engine's hot sections. You can see here in the figure, this is your temperature indicator and this is your oil temperature bulb, which senses the temperature of the oil before it enters the hot section. So this oil is located so that it measures the temperature of the oil before it enters the engine's hot sections. In dry sump lubricating systems, the oil temperature bulb may be anywhere in the oil inlet line between the supply tank and the engine. In a dry sump lubrication system, your oil temperature may be anywhere in the oil inlet line between the supply tank and the engine. In a wet sump lubricating engine, the oil temperature bulb is positioned such that it senses oil temperature after the oil passes through the oil cooler. So in a wet sump lubrication system, the oil temperature bulb is located so that it senses the oil temperature after the oil has passed through the oil cooler. The electrical leads connect an oil temperature gauge in the cockpit to the oil temperature bulb. So this oil temperature bulb is connected to the cockpit by means of the electrical leads. Now coming to the lubrication system operation, how the system is operating. This is your dry sump lubrication system. You can see a figure, a very simple figure is shown of a dry sump. The engine is lubricated by pressurized oil supplied from an engine driven mechanical pump. So in a dry sump lubrication system, we all know that the dry sump has got an independent oil tank. So here in the diagram you can see it has an independent oil tank and the engine, this is your oil tank and this is your pressure pump. You can see this is your oil pressure pump. It has a scavenger pump. We know that in the dry sump lubrication system there are two pumps, pressure pump and the scavenge pump. Then you have, this is your oil cooler, this is your vent line also. You have the temperature gauges here, you have the pressure gauges here and the engine here. So this is your dry sump lubrication system. The engine is lubricated by pressurized oil supplied from an engine driven mechanical pump. So there is a pump, this engine driven mechanical pump, this takes oil from the tank, it will take the oil from the tank through this line and supplies the engine. The oil flows from an external tank to the inlet or suction side of the oil pump. So from the oil tank, it comes to the inlet or the suction side of the pump through a suction screen. So this is your suction screen here. It takes the oil from here to the inlet side of the pump. The external tank outlet is higher than the bottom of the oil sump. So you can see the external tank outlet. This is your oil tank. The external tank outlet is higher than the bottom of the oil sump. This is your bottom of the oil sump. So this tank outlet is higher than the bottom of the oil sump to prevent sediment that falls into the sump from being drawn into the pump. So in order to avoid the sediments being drawn into the pump, this oil outlet, this tank outlet is at a higher level from the bottom of the sump. For the purpose of gravity assisted flow into the pump, the external tank outlet is also positioned higher than the oil pump inlet. So this external oil tank outlet, this is positioned in such a way that this is higher than the oil pressure pump inlet, so that you are able to provide a gravity assisted flow to the pump. The engine driven positive displacement gear type pump forces the oil into the full flow filter. Here you can see a schematic diagram. You can see this is your pump. This is a engine driven pump. It is a positive displacement pump, gear type pump. It forces the oil to the filter. You see the oil is flowing from the pressure pump to the filter. Under normal conditions, the oil passes through the filter, or under circumstances when the filter is clogged, the oil passes through the filter bypass valve. But circumstances when your filter is clogged, then your oil is made to flow through this valve. This is your bypass valve. This bypass valve will bypass the clogged filter here and will supply the oil through this passage to the engine. In the bypass condition, oil would not be filtered. So, in case your filter is clogged or there is some malfunction in the filter, the flow of oil will be through the bypass valve. This bypass valve will bypass the filter and it will provide unfiltered oil to the engine. But we need to understand that unfiltered oil is better than no oil. The relief valve senses the system pressure. Here in the diagram, this is your relief valve. We know what is the relief valve. It senses the system pressure and opens to bypass oil to the inlet side of the pump. So, this relief valve will always sense the system pressure, and in case if the system pressure is more than the preset value, it will open and it will bypass the oil. The regulating relief valve senses the system pressure and opens to bypass oil to the inlet side of the pump once system pressure is attained. Inside the engine, oil flows through drilled passages to the crankshaft, main bearings and other bearings throughout the engine. So, in the diagram you can see this is the path of the oil being followed inside the engine. This diagram is of a Lycoming engine. So, oil flows from the main bearings through holes drilled in the crankshaft to the lower connecting rod bearings. The oil from the main manifold reaches a hollow camshaft. It then further flows out to the various camshaft cams. Here you can see these are your main bearings. We will see it on the real engine also. This is in the diagram. You can see this oil is coming to the bearings. From the bearings it has come to the crank pins and to the pistons and the piston pins. Here you see the oil has come to the tappets. From the tappets it has come to the push rod to push rod sockets and also to rocker arm bushings. So, this is just an illustration we will show you on the real engine. The engine cylinder surfaces receive oil sprayed from the crankshaft and crank pin bearings. So, the engine cylinder surfaces, they are receiving oil which is sprayed from the crankshaft and the crank pin bearings. After lubrication and cooling of moving parts of the engine, the oil drains into the sumps in the lowest parts of the engine. This is your oil filter here. This is your oil sump pickup. This is your oil pressure pump here. This is your oil pressure relief valve, and these are your bearings. You can see these are your crankshaft bearings and these are your tappets, and oil is also flowing through the oil cooler. So, this is an illustration of how oil is lubricating the engine. The scavenger pump quickly picks up the oil collected in the sump, passes it through the oil cooler and returns it to the supply tank. Now, since we are talking about the dry sump lubrication system, we know that the dry sump lubrication system has got a scavenger pump. Its purpose is to pick up the oil collected in the sump, pass it through the oil cooler and return it to the supply tank. Due to mixing with air, the volume of oil collected in the sump increases. This requires a scavenger pump of greater capacity than the pressure pump. We have seen in our earlier slides why the scavenger pump is required to be of a greater capacity than the pressure pump. The oil temperature is controlled by a thermostat attached to the oil cooler. It permits part of the oil to flow through the cooler and part to flow directly to the oil supply tank. So, in the oil cooler, there is a thermostat. We will show you on the engine, real engine. There is a thermostat which maintains the temperature of the oil, and it permits part of the oil to flow through the cooler and part to flow directly into the oil supply tank. The hot oil mixes with the cold uncirculated oil in the tank, raising the engine oil supply to operating temperatures in a short period of time. Now this hot oil mixes with the cold uncirculated oil in the tank. Next is your wet sump lubrication system. Now have just seen the dry sump lubrication. In the wet sump, you do not have an independent oil tank. The oil is stored in the engine. You can see in the diagram, here is your oil which is in a oil pan which is attached to your crankcase. In a wet lubrication system, the oil supply is stored in a sump or pan. You see, here is your oil supply which is stored in a sump or pan. The oil supply is thus limited by the sump or pan capacity. So this capacity, the capacity of the sump or pan limits the oil supply. The oil quantity is measured by a vertical rod that dips into the oil from an elevated hole on top of the crank. So on the real engine, we will show you how the oil quantity is measured, and there is a dipstick which measures the quantity of oil. A screen strainer with a suitable mesh is provided at the bottom of the sump to filter out undesirable particles from the oil and pass filtered oil to the inlet side of the oil pressure pump. So in a wet sump lubrication system, you also have a screen strainer with a suitable mesh which is located at the bottom of the sump, and its purpose is to filter out all the undesirable particles from the oil and pass the filtered oil to the inlet side of the oil pressure pump. So we will show you on the engine the drain plugs, the screen strainers, the filler points, the dipsticks, the rotation of the pump, the rotation of the oil pump which is driven by the engine causes the oil to pass around the outside of the gears. This develops a pressure in the crankshaft oiling system. So we all know that the oil pump is used to pressurize the oil. It is a gear type pump driven by the engine. It causes the oil to pass around the outside of the gears, and it develops pressure in the crankshaft oiling system. The variation in the speed of the pump from idling to full throttle operating range of the engine and the fluctuation of oil viscosity because of temperature changes are compensated by the tension on the relief valve spring. So we have seen in our earlier slide that the purpose of the oil pressure relief valve is to regulate the lubrication system pressure. The pump is designed to create a greater pressure than required to compensate for wear of the bearings or thinning out of oil. The parts oiled by pressure throw a lubricating spray into the cylinder and piston assemblies. So these parts which are lubricated by a pressure, they throw a spray, lubricating spray on the cylinder and piston assemblies. After lubricating the various units it sprays, the oil drains back into the sump and the cycle is repeated. But there is a drawback in the system. It is not adaptable to inverted flying since the entire oil supply can flood the engine. So we have just seen what the lubrication system is all about. So now let us see what are the troubles, what are the malfunctions, what are the snags we can encounter in the lubrication system. So there may be a high oil pressure. Your oil pressure gauge may be indicating high oil pressure. So there are various causes of high oil pressure. It may be low oil temperature, it may be improper setting of relief valve, and it may be a defective pressure indicator. So there are probable causes. In case you have high oil pressure, you can have low oil temperature. It may be because of the low oil temperature. First important thing, in case you have low oil temperature, you need to check your temperature indicator. After that, you need to check the grade of oil being used. So in case you are having low oil temperature, check the temperature indicator, check the grade of oil being used. Now, another reason for high oil pressure may be improper setting of relief valve. We have seen in our earlier slide how the relief valve is set. There is a lock nut, you loosen the lock nut, there is a slotted head, clockwise increases the oil pressure setting of the relief valve, counterclockwise setting rotation decreases the setting of the relief valve. So, improper setting of relief valve may also be the reason of high oil pressure. If that is the case, you need to reset the pressure relief valve. Another probable reason of high oil pressure indication is that your pressure indicator may be defective. So, in case if your oil pressure indicator is defective, replace it with a new or serviceable indicator. So, these were the causes and corrective actions for high oil pressure in case you encounter high oil pressure. Another problem may be low oil pressure. In case if your gauge is indicating low oil pressure, then what are the probable causes? First cause may be a clogged oil filter. Another cause may be improper setting of relief valve. Another cause defective pressure pump. Then defective pressure indicator, low oil level, viscosity of oil is too light, or air leak in the supply line. So, you have so many reasons why you can have a low oil pressure. Coming to the first probable cause, clogged oil filter. Now, in case if your oil filter is clogged, your system may have low oil pressure. In that case, you need to remove and replace your oil filter. Second cause, improper setting of relief valve. We have just seen it in the above case also. In case your relief valve is not set properly, you may also have high oil pressure, you may also have low oil pressure. So, in case if your relief valve is not set, try to reset your pressure relief valve. Third cause, defective pressure pump. Another probable cause, your oil filter might be okay, your relief valve setting might be okay, then your pressure pump might be defective. So, in that case, replace or repair your oil pump. Then another reason, a very simple reason for low oil pressure indication is that your pressure indicator might be defective. So, in case if your pressure indicator might be defective, you have to replace with new or serviceable indicator. So, cases of snag rectification, you have to go step by step. You have to start with very simple reasons and gradually move ahead, and you have to eliminate each and every reason by doing your maintenance actions, by doing your snag rectification. So, snag rectification is all about diagnosis and step by step elimination of all the reasons. Another reason might be low oil level. So, in case if your oil level is too low, in that case also you may encounter low oil pressure. In this case, you need to fill your oil tank to the proper level. Now, another reason is viscosity of oil is too light. Now, in case if your oil viscosity is too light, then you need to drain the system and refill with correct grade of oil. Air leak in the supply line. So, this is also one of the probable cause for low oil pressure. In case if there is a leak in the supply line, if there is an air leak in the supply line, then also you may encounter low oil pressure. In that case, the corrective action will be to locate and eliminate the air leak. As I just mentioned that in case of snag rectification, you have to start with very simple reasons and eliminate each probable cause, and finally you will be able to rectify your snag. So, these are the probable causes and corrective action for low oil pressure. Now, another problem that you may encounter is high oil temperature. Now, in case if your oil temperature is too high, what are the probable causes? Insufficient air cooling. This is one cause. Another cause is insufficient oil supply. Then low grade of oil, clogged oil lines or strainers, excessive blow by, and defective temperature gauge. So, these are the probable causes of high oil temperature. We will see one by one what corrective actions can be taken in these cases. So, in the first cause, insufficient air cooling. In case if the air cooling is insufficient, then also you will have a high oil temperature problem. In that case, we need to check air inlet and outlet for deformation or obstruction. Another reason, insufficient oil supply. In case the oil supply is insufficient, then also you will encounter high oil temperature. The corrective action is fill to the proper level with specified oil. Low grade of oil, in case the oil being used is not of the specified grade or of the lower grade, then also we will encounter high oil temperature, and the corrective action will be replace oil with oil which conforms to the specifications. So, whatever oil is specified by the manufacturer, we need to use that oil so that we do not encounter these kind of problems. Clogged oil lines or strainers. So, there might be strainers which are clogged, there might be oil lines which are clogged, they may also result in high oil temperature. In that case, we need to remove and clean the oil strainers. So, another reason is excessive blow by for high oil temperature. This is one of the probable cause. Excessive blow by might be the reason for high oil temperature. In that, this is usually caused by worn or stuck rings. We need to take the rectification action, we need to take the proper action so that the rings are replaced in case if they are worn or stuck. Another reason for high oil temperature might be a defective temperature gauge. So, defective temperature gauge, in that case we need to replace the gauge, and we might be able to solve this problem of high oil temperature. So, we have seen the probable causes and the corrective actions to be taken in case of high oil temperature problem. Another problem that we might encounter is excessive oil consumption. This is a very important problem. We need to be very careful of this in case if your engine is consuming excessive oil. There might be various causes. First is low grade of oil, then failing or failed bearings, worn piston rings, and incorrect installation of piston rings. So, these are the probable causes of excessive oil consumption. Let us look at them one by one. In case you are using a low grade of oil, then also you will have the excessive oil consumption. In that case, you need to replace the oil with the specified oil by the manufacturer. The oil which is specified by the manufacturer, that is supposed to be used. In case if you are using a low grade of oil, replace the oil with the correctly specified oil. Then another probable cause for excessive oil condition is failed bearings or failing bearings. Now, in case if the bearings have failed or they are about to fail, then also we may encounter excessive oil consumption. In that case, we need to check the sump for metal particles. In case your piston rings have worn out, then also we may face excessive oil consumption. In that case, we need to replace the piston rings. We need to put the new rings. And another reason might be incorrect installation of piston rings. Now, in case if the piston rings are not installed properly, then also we will face excessive oil consumption. In that case also we need to remove those rings and put the new rings properly. So, we have seen the probable causes of excessive oil consumption and the corrective actions taken. As I have mentioned earlier also, in snag rectification we have to move with the very simple steps. We have to eliminate each and every probable cause, and finally we will be able to figure out what is the cause and we will be able to rectify the problem. So, this was all about the lubrication system. We have seen the different components being used in the lubrication system, the different types of lubrication systems. Now, we will see in on the aircraft, on actual aircrafts, the different systems, the wet sump lubrication system, the dry sump lubrication system. We will also see in one of the stripped engines the different parts and how the oil is flowing in that engine. Thank you.